Hey guys, welcome back. So in the Java Basics playlist, we basically studied that how do we make a good object-oriented software and the various in and outs of object-oriented programming, the topics that are not much focused on but are very important in object-oriented programming. So we studied all of that in the Java Basics playlist. If you've not checked that out, I would recommend you to check it out because it would help you a lot in writing good object-oriented software. So this is a new playlist that would help you write more robust and more reliable software now. So how do we make software reliable and robust? We basically handle unexpected situations that might arise. So that means that we'll handle exceptions and errors in this particular playlist. So this is all about exceptions and exception handling. So let's start. First, let's understand what are exceptions. So, as the name suggests, exception are exceptional situations. So, while designing a software and while actually using it, there might arise some exceptional situations that a programmer hasn't thought of, and due to this, the program might terminate if those exceptions are not handled correctly. So, this was a quick overview of what exception is, and let's now deep dive into exceptions and exception handling. First and foremost point about exceptions is that exception is basically an object. So exception is an object of the class java.lang.throwable. So if I just show you the class, this is the throwable class, and exception class extends this class. If we just open the exception class as well. Okay, so this is the exception class, and as we see, it extends the throwable class. So the superclass of all exceptions is throwable. Okay, let's move on. Now, how to throw an exception explicitly? We basically use the throw keyword to throw an exception explicitly from our program. So let's do one thing. We'll definitely go through the points that I mentioned, but let's see an example and first understand what exceptions are and how to handle them, why to handle them. So we'll study all of it. Let's start. So here I have three methods, method 1, method 2, and method 3. I've put in a sysout statements at the start and end of each method just to indicate the flow of the program. So let's see. First, this is a normal code and we'll not throw any exception in it, and we'll see what the program flow is. So basically the main method is calling method 1. Method 1 doesn't take any arguments. So it just prints method 1 start and then calls method 2. Now the execution comes on to method 2. It would print method 2 start and call method 3 with an argument of 1. So method 3 takes an integer argument. Here currently I'm not doing anything, so I'm just printing out method 3 and method 3. So here I'm just printing out method 3 start, and then the execution would come on to the next sysout statement and it would print method 3 stop. Then the execution would come back onto method 2, and method 3 has been executed, so it will print method 2 stop. Then the execution would again come onto method 1, and method 2 has been executed now, so it has been popped out of the stack, and now method 1 stop will be printed onto the console. So let's quickly see if our expectation is correct. And as per our expectations, method 1 start, method 2 start, method 3 start, and then method 3 stop, method 2 stop, and method 1 stop. Okay, so this is the normal flow of the program without any exceptions, and it is working very good. So now let's just assume that method 3 takes an integer argument, that is the file number. All the file numbers are valid except one of them. So file number 1 is not present on the disk, and if method 3 is invoked with the argument 1, we'll throw a file not found exception. So that's an exceptional situation that might arise. So we'll throw a file not found exception in this case. So let's quickly uncomment the already written code. So here the code says that if file num is equal to 1, then we'll throw file not found exception. And as we have studied that whenever we want to throw an exception explicitly from our program, we use the throw keyword. So file not found exception is already defined in the Java library, and it extends the exception class. So we have thrown the file not found exception and we did our job, but the compiler is still throwing us an error. So let's see what the error is, and the compiler says that unhandled exception type file not found exception. So the compiler is not happy and it says that we should handle the exception, otherwise the program would not compile successfully. Now we come on to a question that why do we handle the exception? What is the need of handling an exception? The exceptions need to be handled to maintain the normal flow of the application so that the program doesn't terminate abruptly. So basically, if we do not handle exceptions, then the program or the application would terminate there itself. For example, in this case, if the exception is handled, we could actually create a new file while handling the exception. So exceptions are handled to maintain the normal flow of the application. Okay, so now we have answered the why part. Now let's come on to the how part. How do we handle exceptions? So basically, there are two ways to handle an exception. First is via the try catch block. So in a try catch block, we basically handle the exception in the method itself. For example, in method 3, we have thrown an exception named as file not found exception. So if we place a try catch block here, the exception would be handled in method 3 itself. Let us quickly demonstrate that. So I'm basically placing a try block, and inside this try block I'll be copying the if condition that is there, and then I'll catch that particular exception. So I'll say catch file not found exception e, and here I'll just for now print that file not found exception in method 3 is handled. Okay, currently I'm just printing a sys out, but usually we'll handle the exception according to our use case. Okay, so now the compiler is happy and it doesn't throw us any error. So this was an example of a try catch block. But here, if we see the workflow of the program, what would that be? So as we already saw, main method would invoke method 1, it would print method 1 start, then would invoke method 2, it would print method 2 start, then it would invoke method 3, and then it would come on to here, it would print method 3 start, and then it would see that file num is equal to 1, so it would throw a file not found exception. But we have a catch block here, so it will print file not found exception in method 3 is handled, and then would print method 3 stop, then again method 2 stop, and then again method 1 stop. So this would be our flow of the code. Let's quickly see. So this was our expectation and it is very well correct. Okay. So the first way was the try catch block to handle exceptions. Now the second way is via the throws keyword. So what does throws keyword do? Throws keyword is used to indicate to the invoking code that the method might throw an exception. So the exception is not handled in the method itself. Let's quickly see that as well. Throws keyword is added along with the method signature. So I'll be adding a throws keyword along with the method signature of method 3. So let's quickly add it. Throws. So here I have indicated to the invoking code that method 3 might throw a file not found exception. And here the compiler is happy and it does not give us any error in method 3. But now we see an error in method 2. Why do we see an error in method 2? Because we have indicated to the invoking code that is the method 2 that method 3 might throw an exception. So if method 3 might throw an exception, then method 2 must handle it. So that's very obvious. And if we hover onto here, what does it say? Unhandled exception type file not found exception. So method 2 also has two options now. Either it can add a throws declaration or surround with try catch block. So we'll try both. First, let's surround it with a try catch block. So here we have surrounded the call to method 3 with a try catch block. I'll just add a sys out inside the catch block. So now let's look onto the flow of the program once again. Method 1 start, expected. Method 2 start, expected. Then method it would call method 3, method 3 start, expected. Now the execution would come onto here and it sees that file num is equal to 1. So it would throw a file not found exception, and the exception has not been handled inside method 3. So it would remove method 3 from the call stack and not print method 3 stop. So method 3 stop would not be printed in this case, and the execution would come onto method 2. Here it would see that the exception has been handled. So file not found exception method 2 is handled would be printed onto the console, and then method 2 stop would be printed. Again, the execution would come onto method 1 and method 1 stop would be printed onto the console. Okay, so let's quickly see what happens. So method 3 stop has not been printed in this case because the exception was not handled in method 3. And whenever an exception is thrown and it has not been handled in that particular method, then the rest of the code is not executed. So now a quick question for you, because we have studied exception handling via try catch as well as the throws keyword. The compiler is happy. It doesn't give us any error, but one thing to note is that find not found exception has not been handled anywhere in the code. So method 3 throws a find not found exception. Again, method 2 throws a find not found exception. Again, method 1 throws a file not found exception, and the main method also throws a file not found exception. None of the method blocks have the try catch block in them. Now what would the JVM do? So let's see. Firstly, main start would be printed, then method 1 would be called, method 1 start would be printed, method 2 would be called, method 2 start would be printed, method 3 would be called, method 3 start would be printed, and then the execution would come onto here. It would throw a file not found exception and remove method 3 from the call stack. Again, method 2 throws a file not found exception and it would be removed from the call stack. Method 2 stop would not be printed. Then it would come on to method 1. Again, it would throw a file not found exception. Now it would return back to the main method, and again it would throw a file not found exception. So the JVM would not find the try catch block in any of the methods, and thus it would return. So none of the methods would print the stop statements. Let's quickly see that. So as per our expectation, main start is printed onto the console, then method 1 start, method 2 start, and method 3 start is printed onto the console. Then each of the method have the throws clause in them, so none of the method blocks it is actually handling the exception, and thus the program terminates abruptly. So the exception stack trace is printed onto the console here. So these type of questions are usually asked in interviews, and you must know that if a method has a throws clause in it, it doesn't actually handle the exception. It just indicates to the invoking code that the method might throw an exception. That's it. So we have studied how to handle exceptions in detail. Now, one of the questions that is usually asked in the interviews, and I thought of mentioning it here, is that what is the difference between throw and throws keyword? I think you might be very clear now of the difference between throw and throws keyword. Throw is used to throw an exception, whereas throws is used to indicate to the invoking code that the method might throw an exception. Now, one quick question for you is, could you rethrow an exception? So what does the rethrow an exception actually mean? So now I've handled the exception here, but inside the catch block, I can rethrow this exception. I'll just use throw and then so as expected, the compiler gives us an error. Either I handle the exception within via try catch block, or I can add a throws keyword inside method 2 because I have rethrown the exception in the catch block. So even if I have added a try catch block in method 2, I've rethrown the exception inside the catch block, so I have to handle it again. So yes, we can very well rethrow an exception. Now, a few important notes about exceptions that you must keep in mind because these are highly asked in interviews. So firstly, throws clause can have multiple exceptions. So we can handle multiple exceptions via throws clause. So if I have multiple exceptions thrown inside a method, I can just add a comma separated list of exceptions with the throws clause. So if I just show you an example, I can add an IO exception as well along with the file not found exception. So this is very well allowed. You can add multiple exceptions along with the throws clause. So the next point is exception object can be referenced polymorphically. So what does it mean? That I can handle a subclass exception via a superclass. So that is very well allowed. I'll just show you an illustration of this as well. But first, let's study the why part. It's very simple because at the end, exception is an object and objects can be referenced polymorphically. Let's say method 3 throws a file not found exception, and now I have to handle this file not found exception in method 2. Here I am catching a file not found exception only, but as we all know that file not found exception is a subclass of the exception class. So even if I replace file not found exception with the class exception, the code should work fine if I can access the exception objects polymorphically. So let's quickly see. As we see, the code works fine. So exception objects can be referenced polymorphically. Okay, so the last point to note, and a very important point, is that a subclass exception handler must come before a superclass exception handler. So this is a very obvious point. And why is it so? Because if a superclass exception handler is placed before a subclass exception handler, then the subclass exception handler would never be reached. Let's quickly demonstrate that as well. For example, I am catching an exception class here, and now I'll add another catch block where I'll be catching a file not found exception. As we all know, file not found exception is a subclass of the exception class, and a subclass exception handler should be placed before a superclass exception handler. That's why it should give us a compiler error. Let's quickly see that. Here, as per expectations, we see a compiler error. Let's see what the error is. Unreachable catch block for file not found exception. It is already handled by the catch block for exception. The compiler states us very clearly that this exception has already been handled by the catch block for exception class, and thus this code would never be reached. If I just replace the two catch blocks, it should work fine. As we see now, the code is working fine because the subclass exception handler has been placed before a superclass exception handler. So just a quick question for you. Initially, I told you that all exception classes are objects of the class throwable. So ideally, our expectation is that if we place a catch block with a throwable object, it should be the last one. Otherwise, it would give us a compiler error. Let's quickly see that. Here I'm using the object of the throwable class in the last catch block. Thus the compiler is working fine. But if I replace this anywhere, then it should throw us an error. Let's quickly see. Here I've placed the throwable catch block before the exception catch block, and thus if the compiler throws us an error, it says unreachable catch block for exception. It is already handled by the catch block for throwable. So this was our expectation, and that's correct. Okay, so that was pretty much it about introduction to exceptions and exception handling. We have a lot more to cover in the exception and exception handling playlist, and I'm sure you'll be learning a lot in this playlist. In the next video, we'll study about the types of exceptions, that is checked and unchecked exception. I hope everything is clear in this video. If there are any questions, please let me know in the comment section below, and I'll try to answer them all. And I'll meet you in the next video on checked and unchecked exceptions. Till then, goodbye, have a nice day.